So this will be a test related to my newer engine, or newer 3D engine, in relation to memory usage. So, as noted, this engine is using a combination of raycaster and triangle rasterization, currently performed in software. At the moment, the 3D engine is using, well, it's just crossed over to 45 megs. So 45 megs for Windows reported memory usage. Currently tracked at about 19.6 megs. Yeah, 19.6 megs for total mallocs for track. And 3.2 megs used roughly by the terrain system itself. The 19 megs factor, that also includes any loaded files and other stuff. So current goal is to travel several kilometers from the origin and observe that, well, the previous issue with terrain generation breaking has been fixed. That was that was due to a bug where lighting ticks were spreading over into ungenerated areas and then interfering with the terrain generation process. But has been fixed. That has been fixed now. But yeah. And some other bugs have been fixed as well. So currently at 50.3 megs for Windows reported use. So yeah, now at 1 kilometer from origin, memory usage currently is 50.6 megs. Yeah, in this 3D engine, I don't yet have biomes or anything, so all the terrain does look a bit samey. But also, as noted, it can be noted it's rendering at 320 by 200, so not exactly high resolution to begin with. Yeah. So, yeah, now at about 2 kilometers from origin. Current memory use is 51.3 megs. Current usage by the for total mallocs is 22.5 megs for tracked mallocs, and 5.3 megs total for the voxel terrain itself. Yeah. And tell by looking at the numbers here that yeah, the bulk of the terrain or voxel terrain, it looks like it's probably the 8-bit indexing, and followed by the 4-bit indexing. You can tell that mostly by the memory alloc sizes. Not too much use in terms of the error bit maps, but so yeah. So in this location, it looks like about 26% of the total CPU time is going into the raycasting algorithm, and the remaining roughly remaining 72% is going into raster drawing. Still using the fairly simplistic mobs for right now. Haven't yet haven't exactly done that much to redesign them as of yet, but they do technically work. Current goal is ideally to keep the total memory usage for this engine under about 60 megs. However, given that only about 20 megs is used by the tracked mallocs in the engine, I'm suspecting probably a lot of the memory usage might be going into Windows related things. The tracked mallocs would include the total of stuff related both to the terrain system and to things like file loading. So, yeah. I have reduced slightly, or, yeah, the memory use for file allocations has been reduced slightly by effectively quantizing and coalescing the memory allocations to use more consistent sizes. That reduces overhead due to things like fragmentation. For example, if when reading in reading in region buffers, if you quantize it, say, to multiples of 64 kbytes, that greatly reduces the number of possible sizes, which in turn means more buffers can be reused and less overhead due to memory fragmentation. Similarly, most things within the region system itself are quantized to power of 2 sizes, for similar reasons. And also because many of the structures within the region system happen to fit relatively nicely within power of 2 sizes to begin with. In the case, or in some of these cases, like the overhead of arguable potential inefficiencies from using a larger buffer than strictly necessary for the data is offset by better being able to reuse the same buffers for multiple pieces of data as things load and unload, which is a factorized tuning for in this case, because well, ideally you want the player to move around the world and not have it continuously increasing the memory usage. This involves, well, first all, limiting how much stuff stays resident, and also limiting how much additional memory overhead is created due to fragmenting the available memory, which is one area where quantizing themselves. Within the regions themselves, for the buffers for chunks and similar, that's using, or each region is separate and uses a bitmap based allocation scheme and fixed size cells. In this case, when something like a chunk, or when a chunk is effectively destroyed and then regenerated, for example, while saving a world update, that will implicitly reclaim the storage, because any freed up spans of cells can be further reused for subsequent chunks or other things that are stored in the region, such as entities. But, so total memory use as per Windows reported 52.3 megs. And we'll see if I can find the last on the heap. Total heap memory usage is 22.85 megs. As of the last malloc I've seen here. Because memory is relatively scarce in this case, I was tracking the mallocs individually. So each malloc generates a print statement. That's not true of reused memory, but we can assume, well, since reused memory is reused, we don't have to track it as additional memory or print a message for it. But for each new malloc, it prints a message at the moment. And that is more or less all I had to say for the moment. Yeah. Well over an order of magnitude less memory required than, for example, in something like Minecraft, but yeah, or even in my past 3D engines, which is kind of what I'm shooting for. Performance is secondary in this case, because I'm not strictly trying to compete with like Minecraft in terms of rendering fidelity or world size, which are both somewhat less.